So here's where we're at. Honest opinion, how many of you learned bio so far? Ms. Shinard, will you handle the chat if we open up a chat on the... All right, let me open that up so that if anything comes up. It looks like... Okay, so those of you online, if you have any questions, Mrs. Shinard is sitting in the chat. She can interrupt me, and I will gladly stop what I'm doing and teach you all about whatever you have a question about. Honest opinion from those of you back there. Dom's the sun really bright? Really tired?
Yeah, I can go on sleep last night.
Oh man, that stinks. Dom on Saturday ran 12 miles with some friends. My legs are hurting. I slept like a rock last night. Because I was here at the football game until like 10 o'clock. Then I drove down to the Brigantine Friday night. Didn't get in until about 1, 2 o'clock in the morning. Woke up, ran 12 miles starting at 8 a.m. And I just woke up the next day, came here because I love this place. So what happens, man? I just love teaching you guys. I just want to make a difference in your life. Just love you guys. Heart for you, buddy. We're friends. I hate to believe it. I hate to tell you that, Don, but we're your best friends. Someone at the door judging me already?
No, I just I don't know what's.
What'd you say? It was limping? Wiping. Oh, that's the guy goes around. His job is literally to clean all the handles in the building. He walks like 8 to 10 miles a day just cleaning handles. So, it's okay. All right, let's see here. Cassidy, you have a really important job. Is this room ever going to be warm at the temperature? Do you feel like really, really warm right now? Right. Okay, this room will never be warm. If a principal is standing at the door, I just need you to say, it's hot in here. That lets me know that there's a principal there and I shouldn't be making fun of someone. Do you understand how important that job is? Yeah. Like seriously, if you do not say it, I go and make fun of Dom for having really, really small arms, and then we're all of a sudden we have a huge problem. What's wrong, Dom? Do you think I forgot that? Yeah, I don't forget things. I didn't get to this position because I forgot things. I actually really don't even remember how I got to this position. But we're good. Back to my honest opinion or honest question for you. I'm going to sit down because I can. How many of you have learned anything over the past month? Thank you, Dom! Woo! Well, actually, I should clarify. How many of you learned anything in bio class over the last month?
I can remember.
Are you really going to tell me right now that you haven't learned a single thing in my class? Even
no,
though
I have. I was about to say something like. Now I forget.
It's okay, Dom. Hey. This is like first day of school on steroids. It's like I gave you summer homework pretty much, and now we're coming back to school with that summer homework. Right? Right? That's kind of where we're at. Yes, no, maybe so. How many of you maybe didn't learn anything new, but reviewed stuff? So you kind of like at least remember that there's some different things associated with bio that you should have known and whatnot. Bryce, I'm going to need you to take that headphone out. Thanks, buddy. So let's talk about what we've learned so far this year. We talked about the scientific method. Did anyone learn anything new about the scientific method? How many of you remember the scientific method? Okay. If I asked you right now to list the steps of the scientific method because it's on a test, could you do it? No. Okay. After the scientific method, we talked about characteristics that all living things have in common. What was the acronym we used for the characteristics of life? Sean? RAREHOG. How many of you remember the characteristics of all living things have in common? If I asked you to list out what RAREHOG stands for, how many of you could do that right now? Okay. Then after Rare Hog, we went into chemistry. We talked about structure of matter and the idea of atoms. How many of you could right now list the subatomic particles, where they're found, and their charges? So you're my favorite, Dom. I don't care what everyone else says. Right? You're my favorite. Just don't tell my wife. After that, we talked about water, major properties of water. How many of you can identify the major properties of water? Okay. So here's the deal. You've just missed out on a month of instruction that you need for the Keystone exams. All that stuff that I've taught you so far is on the Keystone exams. You have to pass them in order to graduate high school. You better go back and review that stuff if you don't know it. I don't have time to go back and review, unfortunately. I have to keep moving forward. So we got to make sure that we are still moving forward. We're still paying attention. We're still learning stuff. The online assignments, you've got to make sure you're doing them. Tomorrow, you guys will all be sitting at the camera. You're going to have to make sure you're paying attention. All right? Any questions about that? Not trying to be mean, guys, but we got to hold ourselves accountable. Right? Grades aren't the only thing here. It's all about actually learning stuff. So today, here's what I want to do. I'm going to need your cooperation. This is going to be my first time trying to do this in the current format we have. I want to try to run a lab with you guys. I want to run a lab so that we are going to go through the properties of water. What it's going to do, it's not going to take the whole double period. All right, it'll probably take us maybe 35, 45 minutes to do, in which case then you'll be able to complete some other assignments. Kind of we can review the different properties of water, go over some things, and then that is that. All right, any questions about that? All right, so let me hand out some papers to you. Okay, perfect. Yeah, this is just for today, and we'll get to those. We'll make sure we hand them out before the end of the class. Some people don't ever come back for a price. Back alive, please. Can't really tell if you guys are like laughing at my jokes or what, but it's pretty good. Did you get a flight all last night, Friday? Nope. You haven't been today, right? You shaving?
Yeah, the other one.
Are you starting on David?
Yeah.
Cool. So did you play on Saturday with the sophomore team or no?
Yeah, I played on it too. It was against Pratt.
I know. It was a scrimmage, right?
Yeah.
How'd it go?
It was we won.
It was a scrimmage.
But like midway through the game, they turned into like an actual game.
That's cool. So you guys did a couple like rep plays, and then you guys decided let's just actually play a little bit.
Yeah, we would go like 10 plays each and then switch.
Yeah, 10-10, and then scrimmage it out. All righty. So let's start. I guess I got to share this with the people at home, huh? It probably would have been smart to put this online. Here's what you guys are going to do. Right now, I want to start with defining these different properties of water at the top. So we could do this a couple different ways. One, you can remember the properties of water as I talked about them. Two, you can look them up as we go along, because I would hope that you would kind of understand. So let's say cell phones can only be out if you are looking up a definition, all right? Or if you want to use your computer, you're more than welcome to use your computer. If anyone needs to charge their computer, you're not going to really be using your computer near water, so we can plug your computers in if you'd like to charge them. Do you think we could scan that in? Can you scan that in? Maybe upload it to Canvas? Mm-hmm. Awesome. Fantastic. All right, so first one, we're going to go through this as a class. Don't try to define everything yourself. No one needs a hero. All right? Haley, you already looked up definitions? Yeah. You're so much better than your brother was. That was awesome. All right, all your brother talked about was playing Fortnite. Yeah. I don't really know, actually. He was, I try to forget that class as much as possible. Here we go. Polar molecule. What's it mean to be a polar molecule? I'm going to write this stuff on the board. So, what's it mean to be a polar molecule? You guys, again, don't need to look up definitions right now. I'm going to go through them with you. So, what's it mean to be a polar molecule? Yeah, like something sticking in the bottom. Ah, gum or something. Ah, it's still there. There. Don, you cool if I bring my shoe over and you get the rest of it off?
Sure.
Yes! Dom, you and I have become best friends really quick. If anyone else is jealous of Dom and I's relationship, you guys can feel free to step up. Polar molecule, what's it mean to be a polar molecule? Polar molecule, what's it mean to be a polar molecule? Polar. I know I talked about it offline. I know you guys paid attention then, right? You didn't just like log into Zoom and fall asleep, did you, Dom? You sure?
Pretty sure a few things.
What's it mean to be a polar molecule? Polar molecule. Polar molecule, what's it mean? You guys tell me you didn't watch any of my videos? What's it mean to be a polar molecule? Polar molecule. All right, look it up. What's a polar molecule mean? What's it mean for a polar molecule? Look it up. Polar molecule. What does it mean to be a polar molecule? Who's got an answer for me that makes sense? Anthony, back there, you got one? So it has to deal with the distribution of the electrons. How so? What does it mean then? To be a polar molecule, what's that mean? Has a positively charged end and a negatively charged end. Yeah, you're right. You can read it online. Those of you online, I'm talking to you. Hello. Mrs. Chenard is uploading the document right now, so in a couple minutes, check on Canvas and you'll find this document. You'll be able to kind of follow along with what we're doing. That's your right here. Still cold and get warm. You're never going to be warm. So a polar molecule has a positively charged end and a negatively charged end. Then it's like magnets. The positive end wants to stick to what end? Positive sticks to negative. Very good. So water is a polar molecule. So what it actually does is it has positive ends sticking to negative ends, and they kind of hold it together. And what type of bond occurs between water molecules that holds them together? That positive end to that negative end. What type of bond is that between molecules? What type of bond forms between molecules? Who wants to answer that one? What type of bond forms between molecules? There's three options You can remember all three of the different types of bonds. You have a 33% chance of guessing it right. Do we want to list off the type of bonds and then guess which one's right? Give me a type of bond. Dom. Hey. That's why you're my favorite. I really don't care what Coach Wilmot says about you. You are my favorite. Hydrogen bonds hold water molecules to other water molecules. Very good. All right, next property, adhesion. What does it mean, or what does adhesion mean? Sean, hey, welcome to the class.
Hi, when water sticks to non-water.
Very good, when water sticks to non-water. When water sticks to non-water molecules. So like the water bottle, the last little drop at the bottom, that's adhesion, water sticking to it. Water sticks to the glass on your car window. That's adhesion. It actually wants to kind of bond a little bit that way. Next we have cohesion. Cohesion. What's cohesion? If adhesions when water sticks to non-water molecules, what's cohesion, Sean?
When water sticks to itself.
Sticks to itself is kind of tricky to describe it as like its own body, but when water sticks to water, when water sticks to water, yes. They cooperate together. Join, like twins. And if co, then cooperate, and join. Different ways to remember the water sticking to water molecules. Any questions so far? You guys all excited to be back in school and taking notes again? You're like almost rolling your eyes there, like not having this, huh? It's so boring, huh? Yeah. We haven't even gotten to the boring part of biology. Trust me, I'll really slow it down, make it as boring as possible for you. Wait till we start to talk about organelles. Yawn. And just put sleep through that one. Oh my goodness, is it bad? That's something to look forward to, though, right? Yeah, that is. Yeah, that is. All right, where are we at next? Surface tension. So I hope you guys are okay with this. I usually don't teach with a lot of PowerPoints. I usually teach this way, where I write on the board, you write on the notes, and I think it really works well. How many of you would rather have me teach from PowerPoints? Fantastic. So look at me, I'm cool. How many of you just didn't even want to respond to that question? Thanks, Ari, for being honest. I like this route. Lily, by default, I definitely like you. I usually don't like people that wear glasses. Intimidating. They automatically look smarter than me. And sometimes I think they might be like superheroes, like Clark Kent. Are you like a superhero? You just take your sunglasses off, and all of a sudden you're like a hero. No one can recognize you. In case you are, I'm on to you. If you could be a superhero, what would be your superpower? I don't know either. I kind of think I like to read minds.
But what if you couldn't control it?
What if I could just like predict the future by like an hour? That would be a fun one. If I could predict the future by like an hour, I could win the lottery all the time. Tom's like, yeah, we could. Then I could buy a Lambo. Yeah. I have all the chips in my Lambo. All right, Tom?
I would want to fly.
You want to fly?
Yeah.
Fly is definitely my number one superpower. I wish I had. Flight seems like a really cool idea. Now, do you think it's like flight where you have to like mechanically fly, or do you think it's like flight in that like you can control physics and like jump super high and like in theory you're jumping to a distance, or you think it's just some weird power that you can just like all of a sudden levitate?
I'm thinking like mechanically. Like a bird.
You want to be a bird?
Would say?
You want to be a bird?
No, I don't want to. Look. No, I don't want to be a. No, I don't want to be a bird. But I want to fly.
Like a bird.
You want to be a bird?
I didn't say it, you did. I'm not the one putting words into your mouth right now. Surface tension! What's surface tension? What's surface tension? What is surface tension? Any ideas? You don't have to have like a textbook definition. You just kind of describe what you think. Surface tension. Sean.
Tension on the surface of the water.
Tension on the surface of the water. Yes. What's that mean? Describe it to your like kindergartner brother.
Pressure on water.
Pressure on water? I don't think that would be a great definition. What do we think? What do we think? Surface tension. Surface tension is because water at the surface, they bond together really, really tight, much tighter than deeper in the water. So there's a lot of those cohesion bonds. Water can actually support weight on top. The surface tension. Because of strong hydrogen bonds, water can support weight on its surface. Makes sense? How many of you have ever seen a bug standing on top of water? Because water can actually support their weight. Water striders, they have really long legs, can spread out all their weight on top of water. Sean?
Didn't they like discover a new species of spider in Texas that a couple of months ago that can walk on water?
Probably. Spiders are usually pretty light with 8 legs and can distribute their weight across many different points of contact. So yeah, it makes sense. There's actually a type of lizard, a striped basilisk lizard, that can run across water. It's got really, really big feet and it runs really, really fast. It kind of like slaps the water. And by doing that, it actually can support itself and it runs across the water. They call it the Jesus Christ lizard as a nickname because Jesus could walk on water, supposedly. I don't know. Seems like a superpower I don't know if I would need. But I guess if I was like running from the cops, it'd be nice to be able to run across water. Am I right, Dom? Good. Can I erase the board? Bryce? Bryce, do you need to move closer to see better? I see you threw on your glasses, so I didn't know if you were like trying to pull like a Clark Kent here. I actually wear glasses too. Wear this contacts. Or do you guys all have like blue light glasses or something like that?
Mom.
Oh, Ben wants to come in. Did someone just yell, Mom? Oh, Nevaeh is the only one not muted, so now she got busted. All right, sorry. We're back. I'm going to erase the board. Maybe Mom will come in and help me. The next teacher who's decently short, I think I'm going to keep messing with it, just put all the erasers up at the very top. I should put the markers on top of the erasers too, really mess with them. Anyone have this? That's taught bio. Okay, that's a good one. See if I mess with someone, right? Stay well. Next property of water. Heat capacity. Can everyone read the board okay? Already way back there, you can read it? No problems? If you want to move closer, man, I don't mind. There's really only 2 seats for you, and I don't really know if I want you that close to me. I mean, like, we're friends and all, but.
We're too fun at that.
Okay. All right. Heat capacity. Water resists change in temperature. Water takes a lot of heat or energy to warm up, but then it also takes a long time to cool down. Like I said, I was down the beach this weekend, went in the ocean, worked on my tan. The water was not that cold. Yeah, it was like cold, but not like, winter cold, not like it's been 50 degrees outside this morning cold, right? It was just kind of nice, fresh water, fresh ocean water, refreshing, some would say. You guys getting bored yet? Yeah, I understand. It's biology. It's boring. I tried my best here. Can't really make as many jokes as I normally would. There's a camera. I haven't threatened to kill anyone this year. It's a new record. What are you looking at, Sean? Are you laughing at that statement, Sean?
No, I'm reading the board above you.
What are you showing off that you can read? Just because I'm illiterate, you're making fun of me? Because I can't read? You're making fun of me. Thanks, Sean. Really appreciate it. I love that. Thanks. Capillary action. Also referred to as capillarity. Capillary action, capillary. Anyone know what this means? Water has the ability to defy gravity. It actually can flow up. You can actually get water to flow up. The way it flows up, it kind of works as a little combination of cohesion and adhesion. And in doing so, what it's going to do is it's going to go from the ground up. So we can actually see this happening in trees when they pull water from their roots up to their leaves. Some trees are over 100 feet tall, over 200 feet tall, and they're pulling water all the way up to their leaves for photosynthesis to take place. So far, so good? Any questions, comments, concerns? Is class over yet? No. What we got? Another 10 minutes at first period alone. Then I got a whole lab period with you guys. It's going to be great. All right. They can see it, right? Is it really? Well, is it right now because it's focused on me, the camera? If I move out of the way, how does this look? Because I'm looking at it on my screen. Like I can kind of read it.
Yeah. Yeah, that's the way. I don't know.
Now try pinning that to make that the biggest screen. Instead of doing a gallery view, do
Okay.
a big view and see how that works. So they can kind of
Can,
read it. Yeah, it's
yeah.
not, this is what they told us to do, right? I could go to the laptop, but I think this is a little bit easier because I can record it. And then if I need to write on the board with the laptop, I could. I got that available to go. Yeah. All right, last property of water. Hopefully you guys will know this one. The idea that water is referred to as the universal solvent. What's a solvent? What's a solvent? What is a solvent? Sean.
Something that can dissolve something else.
Very good. Something that can dissolve something else. Water is a very common solvent. We use it to dissolve many. How many of you made any lemonade this summer? Iced tea? Gatorade? How many of you ever put a powder into water to make a drink? Tang? You like drinking a lot of Tang, Anthony? No. You ever have Tang? Anyone ever have Tang? So Tang was this like, it predates me. It was like this orange, powdered orange drink that got really, really famous because apparently it's what they took. They sent up in space with the astronauts and stuff like that. So it's like this orange, like powdered mixed drink. It's not that great at all, but it's Tang. But whenever you put a powder in a drink, like you're making like a lemonade, a Gatorade, or anything like that, you then mix it up, it dissolves, right? Thanks for agreeing with me. I really appreciate that. So that dissolving is because water dissolves it. Water is referred to as the universal solvent because water can dissolve many different substances. So water can dissolve many different substances. And today what we're going to do is we're going to kind of demonstrate some of these properties of water. And then you guys will actually see them happen firsthand. So we're going to do it at your desks. I'm going to try my best to make it work. We'll see how it all goes. All right. I got a lot of little question marks I got to figure out before I get to this stage yet. But anyone have any questions about the properties of water right now? Anyone have any questions at all? All right. What do we got? About 5 minutes left in this period. Let me see if I can get materials distributed out to you guys for the lab. Those of you at home, we'll be setting up the lab here, and I'll do it on the demo desk as we go along with everyone around the room. So here's what I need to do. Let me get 5 minutes of everything up. each person is going to get 2 of these, 1 of these. And then you fill with water, these would be 1, so we water will be 3 of water.
Both need to be filled first, or first?
Well, all 3 will eventually, but actually we can probably have everyone do it themselves. Let me just label some of these, real quick. We'll get 10 of them labeled and more. So those of you guys sitting down right now, just sit tight for a second. Relax. Down in a second. That will those will be filled with water. Let's just put, we'll put the beakers in front of each, we'll put each person and I'll find out. All right, we can have them go in there, yeah. So who did you guys have last year for IS? Who did you have? Murray? How many you? Bird? She's just down the hall. Did you see her this morning? Haley, who did you have? You don't remember who you had for science last year? Oh, it's Tanya. Lily, how about you? Who'd you have? You don't remember or you don't know? It's only a year ago, guys. Bryce, who'd you have? Miss Mary? Anthony? Mr. Dillon? Dom, how about you? Okay. Artie? Mr. Sinzak? How about you, Sean? Who'd you have?
Mr. Dillon.
Mr. Dillon. Mr. Dillon's our new golf coach. Any of you guys do any sports? Dr. B, how are you? Great. Prepping a little lab we're going to do next period, so yeah, we're going to give it a shot.
All right.
What could go wrong? Everything could go wrong. Yep, everything could go wrong. So. Fine. Yeah, we'll get better. Sorry. I like to think that I'm doing pretty good right now. I'm trying to figure this out. Have fun. Thank you. All right, so let's talk about what you guys are going to be doing in lab today. We got time? Or you want to just let the bell ring? You guys take a couple minute break and then we come back and talk about directions. Bell ring? Okay. Dude, one job. One job. One job. He's right behind me. Like you're literally the only one who can see behind me right now. One job. One.
Lauren, how much soap needs to be in this? Just foam or something?
I was gonna grab some dish soap, but that's fine. We'll just mix it in. Mix it in with the pipettes. So I can trust. What? Not trust already? Oh wow, you're an idiot. Yeah, you can't trust me. This is great. I don't have to tell you guys like all these warnings about spraying each other with pipettes. Because you have to close to each other. All right, everybody? Hang in there. So, you guys are getting 2 pipettes right now. One's got a yellow flag on it. One doesn't. I'll explain everything in detail. We'll make sure we clean all this stuff down before we put it away. I don't think there's anything else. You mind telling me? Oh, I'm gonna just fill it out onto that, like 2/3 of the way. And like get yourself soaking wet. It's gonna be really hard to explain that. The 250. If you guys want to take a little walk, just to stretch your legs because you've been sitting down, you're more than welcome to. They're not really going to let you go too crazy, but feel free to go for a quick little walk around and then come back into the room. If you go out of the room, you have to make a right. If you want to just get out of your seat, now's the chance to do it, guys. Right, you can Snapchat together. Filters on. Are the fluffy things on? Also, I'm still learning your names. Oh, sweet. So let's put a fun little puppy filter face on. Okay, we can't really open our mouths with a mask on. It's tough. Alright. Okay. Next time, maybe. Next time. I'm gonna go. Oh, I can't run short and fast. Dish soap. Dish soap in there. This is a new room for me, guys, so I gotta find where all the little treasures are. It's like hiding this secret. People you don't know. Ah! All right, let's see. We're gonna keep waiting a minute. Let me see if I got everything we need. Everyone has 2 pipettes, 2 paper clips. Everyone needs, oh, shoot. How do we make that work? Paper towel for everybody. Actually, probably gonna need more than one. So those of you guys with computers on your desk, you're gonna want to put those computers away. Just because we don't want them to get wet. directions, everybody. I'm gonna come and bring some water and put it on your desk. Don, why don't you clear your desk of your computer? You don't need that. Okay. I'm gonna put a couple things on your desk. First thing I'm gonna put is just a regular beaker of water. Okay. Put the pipette that does not have the yellow tape on it in that regular beaker of water. I'm gonna bring a little beaker of water over. What class are you in? What's your name? Are you in this class? Are you in my third period?
Third period. It's only second period, huh?
My schedule.
You have lab on day 3.
It's day 1.
Yeah.
Sorry.
It's okay. Whew, sorry guys, I panicked.
Is this what we're handing the smaller beaker?
Yeah. So back to what I was saying. The clear beaker with no yellow gets the pipette with no yellow. The pipette or the beaker with the yellow tape on it gets the pipette with the yellow tape on it. Do not cross-contaminate them. They do not cross-contaminate. It's really important. They do not cross-contaminate. Okay. Everyone understand that? When you get the one with the yellow tape, just give it a little stir. All right, just mix it up with the yellow pipette. And I'll explain what we're doing. Yellow goes in yellow. Nothing goes in nothing. All right, so give your beaker with the yellow pipette and the yellow dropper a good stir. Mix that up really well. Try to mix it. It's just soapy water. The other one's just regular water. So we've got soapy water and we've got regular water. That's it. It's the only difference between the two. So far, so good. Everyone's with me? Oh, I'm sorry, Don. I didn't mean to forget you. I did not mean to do that. Okay, so now, one of the things we want to look at, we're going to take a look at this first little activity of our. No. I needed it just because I was going to. I thought I needed soap, but I found some soap. All right, so everyone's going to get a penny. Please don't steal this. It's my penny. What we are going to do is we are going to see how many drops of water we can put on a penny. How many of you have done this before? Drops of water on a penny. Okay, good. So you've got experience with it. Now, here's the thing. Here's what we need to do. All right. Right now, we have a cleaned penny, and we are going to start with the clean water. So we're just using the non-yellow situation. What I want you to do, let's organize our desks all the same way so we don't make a mess. Step number 1, take the penny, just leave it right onto your desk in the center. Put your paper towels in the top left corner, put your worksheet, let's put your worksheet on the bottom or underneath the desk right now, just out of the way so you don't get water on it. Then we have our 2 beakers up on it. And so far so good, everyone kind of looks the same way. Now what you are going to do, let me get them on the street up here, so that those at home can watch along. Right, let's see. Can you see the beaker? No, you can't see the beaker, huh? Oh, that's a shame. Okay. What I'm going to do, let me just give this a good stir. Okay. Now, let me erase the board really quick. Come on. All right, ready? First thing we're going to do is we're going to take our penny. your penny laying on its side. It's actually a lot smoother than that. I'm just not really good at drawing it. All right, here's the top view of it. What you are going to do is you're going to take your dropper, that's the very tip of your dropper, and you are going to drop a drop of water onto it. What you want to do is you want to make sure that you are not touching the dropper to water that might be building up on top of your penny. I want to see how many drops of water we can put on top of our penny. All right? So what I want you to do right now, right on the desk in front of you, keep putting it drop by drop, keeping a count in your head until the water falls off. Okay? So you're going to go 1, 2, just keep adding drops of water onto your penny until you start to see this big bulbous mound forming on top, and then keep going until it eventually falls off. So go ahead and start doing that now with the regular water. Regular water. We're keeping a count in our head. $26. You can use one of your paper towels to really wipe it off and dry off the penny. What'd you get to, Lily? 48. What'd you get, Mark? 43. Okay. Sean, what'd you get?
40.
Pass? 40. Dom?
39.
Bryce? Anthony? 38. Artie?
40.
40. Okay. Now, here's what we need to do. Dry off the penny as best you can with your paper towel. Dry off the penny as best you can with your paper towel. Get it as dry as possible. We're going to repeat the process now. With the yellow pipette and the soapy water. Yellow pipette and soapy water. So we're going to do that now. So repeat the exact same process. Give it a good mix. Anthony, what'd you get? 15. You're so bad at this. Everyone else gets so much higher. Just kidding. I'm at 8. Lily, what'd you get? 20. Haley? 31. Anyone else done? Cass, what'd you get? 26. Bryce?
24.
Sean?
21.
Artie?
13.
13. Oh, what was it? 30. Dom?
32.
32. Is that everybody? Yes, no? Got everyone? All right, let's find the average. Does anyone have a quick calculator? Do the average for me. Thank you, Alexis. Anyone else have a calculator? Dom, can you add up all of these? This is the black numbers. Alexis, you'll take the blue numbers. All right, and then we're going to divide it by 9. Right here? What was the first number? 318? No.
I got 23.5.
23.5. That sounds about right. You might have added it. Did you divide by 9? What do we got here? Forty minus 5, 235. 78. Might be accurate. 6 plus 3 plus 33 plus 40 plus 33 plus 33 40 divided by 9. 39. 11. That's okay. 39.11. Why was this one higher than that one? You guys all did it. Why was this one so much higher than that one? Sean.
The water was soapy, so when it made contact with the pennies became slippery or something.
It's a good guess. Maybe it became slippery. Well, what's actually happening? What property holds water to other water molecules? Because they started to form this big ball, right? Everyone had like a kind of like a bubble on top of their penny. What held those water molecules to other water molecules? Artie. Close. Cohesion. Very good, Artie. Very good. Cohesion is holding them all together. Now, what happens when I put soap in there? Why? What is actually holding water molecules to other water molecules? Why do they stick together? Why do water molecules stick together?
Well, it's getting stuck together by non-water molecules.
No. It has to do with the water molecules sticking together. Why do water molecules stick together, Artie? Good. And that's what type of bond? You're there. You're so close. Bryce, you know? What type of bond holds them together? Because they got a positive end and a negative end. Sean?
Hydrogen bond.
Hydrogen bonds. So the hydrogen bonds are holding the water molecules together, right? Now, what happens when I put soap in there?
Hydrogen bonds get broken.
They don't get broken, but there's now something between them. Right? So there's something between them. So now they're not as strong. So they break easier. And that's why because the water broke apart easier and it pulled apart and spread out, right? Makes sense? Okay, you can put those two beakers off to one side, you can put the penny off to one side. Remember, you're not stealing that penny, that's my penny. You steal it, I'm really, really upset. Alright, now, next thing we're going to do. Take one of your paper towels, which is nice and dry, and roll it up into a tube. If you don't have a dry paper towel, that's okay. I will get you a dry paper towel. You're rolling it up into a tube. Very good, Artie. I'm pretending to be pirates. Yeah, good. All right, so now I gotta get you some paper towels. the paper towels or anything else? How does that go around? Towels. 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 Again, we're rolling it up into a tube, please. Roll it up into a tube. Get a better one. Now, what you're going to do, you're going to take that tube that you've made out of the paper towel, and what I want you to do is very carefully go to that big beaker and put it in about that much of water and hold it there. So you might have to kind of hold your hands across like the beaker and just hold it and watch what the water does. So you're going to just touch it in the water and then watch what the water does. All right, you need it. Here, I'll give you my tube. This is a professionally made tube, so please don't ruin it. So what are we seeing happening? Describe what's happening.
The water's going up the paper towel.
The water's going up the paper towel. Why? Why is the water going up the paper towel? Artie, it's not pressure. Not pressure, because if you put your finger in there, you just dip your finger in. Does it go all the way up your finger? Why not? Why does it go up the paper towel but not up your finger? What's going on there? What property of water is being demonstrated? Sean.
Capillary action.
Very good. Capillary action or capillary. So what's actually happening is water, it starts with adhesion because the paper towel is a non-water molecule. So water molecules are sticking to it and they're bouncing back and forth going up. And as they go up by sticking back and forth, they're pulling the rest of the water molecules up through cohesion. So it's a combination of adhesion and cohesion working together. Any questions about that? All right, take that paper towel out, put it aside. You gotta wring it out if you want to. Wring it out a little bit because we don't need all that extra water coming out to make a difference now. All right, now comes the biggest challenge. I promise you right now you can do this. We're going to demonstrate surface tension of water, the ability to support weight. In front of you have two paper clips. See if you can get both paper clips to float on the water in that big beaker. I promise you it can be done. Get the paper clips to float in the water. Oh, nice job, you got one. We get both of them floating at the same time. You can use the clean water pipette. Yeah. Show off. Show off. Show off so you get the two right away. Did it work? Be very gentle with it. You got one to float earlier. Did you get one yet, Bob? that sheet a little bit, bending the paperclip ever so slightly, spreading it out, and that allows more points of contact. It's a beautiful way to try that. Use that little handle. All right. So pretty easy to see the different properties of water in action. Anyone have any questions about the properties of water? All right, here's what I would need from you. Make this easy. Now I'm going to come by and kind of collect all those materials. Clear this space here. As I come by, just put your stuff on the desk, leave the pipettes in the beaker there, but your penny and your paper clips, pull them out. I'm going to collect them separately, or I'm going to collect them on here, just keep them separate. Clean off or dry off your desktop. If it's not dried off, you just let me know, I'll give you another paper towel. And then what you can do is you can finish up the worksheet that went with that lab. Right? Right. So you guys can go through and finish up the worksheet. That's what you're doing now. For the remainder of the period, you're just finishing up the worksheet. So pretty easy rest of the day. Any questions, feel free to ask. I'm glad to come over and help you. If anyone needs paper towels to dry off their desk, let me know. I'm glad to come over and help you. If anyone wants to drop out of school, let me know. I'll gladly come over and help you. Is it working? Pick it up. Reach over here. Sorry. Trying to get them all in your space. So some of the activities we didn't do, like the activity number 4 we didn't do, don't worry about that. I think we did the other activities, right? You guys can answer all those questions associated with the other activities. Let me go check in with those online. Anyone have any questions online? Feel free to use the chat. Those of you hanging in here, anyone have any questions online?
What do we do with the paper when we're done?
You're going to submit it through Canvas. I'm going to create an assignment, and you will take a picture of your worksheet or scan it in, and you will submit it. I'm not going to be collecting any paper copies of things. So if you give me a minute or so, I will make sure that is posted up there. Anyone have any other questions? Actually, I can do that. I can pull this laptop now. I can work on that while. While we're going along here. So I'll pop in front of this camera here real quick. Anyone have any other questions about anything? And if you guys are missing any work, now's a chance for you guys to go back and turn in some late work or missing work if you have any assignments that have not been turned in. Remember, if you submit something, just email Mrs. Chenard to let her know exactly what you submitted so that she can keep a record of it. I'm just going to move over to the computer over here so I can pull up Canvas and get this assignment created for you guys.
Mr. Maloney,
Yes, Sean.
so I'm trying to log into Canvas through my phone,
Mm-hmm.
and it's saying my password isn't
I don't know how to help you there. Well, I'll take a look at it in 1 second, okay?
working. Okay,
Are you on the Neshaminy Canvas or Canvas in general?
can't do the app.
So I think did you type in your login name as your student ID at Neshaminy, at nsdstu.org? All right, so everything is online, so you guys can go onto Canvas. If you're done, Mr. Chenard has put it as a Canvas worksheet. So. And that's definitely your student number?
Yep.
Sure not missing a digit?
Yeah.
Only 5 numbers? Thought it was bigger than that. So, you have 6 digits or you
Yeah. 795471.
and how many digits do you have right now?
795471.
I have no idea what's going on. Yeah, I didn't see the one there. I really have no idea what's going on.